Okay, in this section we're talking about the chain rule. Now, you will use the chain rule if you have a function inside of another function. So you start with a basic power rule. In this case you'd bring the n down, then decrease the power by 1, and then remember to take the derivative of the inside. Okay, so here's our first one. You can see here what I mean by an inside function. So what we're going to deal with first is to bring that power down. So when I bring the power down, I have a 100 out in front. I keep the x cubed minus 1. Do not change the x cubed minus 1. Using the power rule, I decrease my power by 1. 100 minus 1 would give me 99. Now here's the kicker. What you have to do now is you times this blue part by the derivative of the inside. So here's where the derivative goes. It's being multiplied on the back. So my derivative of x cubed minus 1 would be 3x squared. Now the 3x squared and the 100 can be put together. 100 times 3 is 300x squared. And x cubed minus 1 to the 99 would just be brought down. And that's your answer. What I want to point out about this particular one is many times people are tempted to take the derivative right here where you see this star. Do not take the derivative there. The derivative is a separate step. So do the entire power part first, then take the derivative of the inside. Let's try a second one. Okay, looking at this one here, I have a function underneath a radical. So the first thing that I would do using algebra is I would rewrite this in a usable form. So I see I have an x squared plus 1 here. Well, underneath a radical, that puts that as a 1/2 exponent. So now that I've rewritten it in a usable form, I can start my calculus. So I'm going to take the derivative and I have to use the power rule. So my power right now is 1/2. I keep the x squared plus 1 just like it looks. I decrease my power by 1. Don't forget, you have to take the derivative of the inside. So the derivative of the inside here is 2x. So then we have to clean it up. The 2x and the 1/2 can go together because they're both outside the parentheses. So remember, 1/2 of 2 would give me a 1 there. So I'd have 1x out in front. Here's where the x came from. 1x out in front, x squared plus 1. 1/2 minus 1 is a negative 1/2 exponent. Now I want you to always use positive exponents. So this x squared minus 1, that's plus, x squared plus 1 is going to move to the bottom. And that's what your answer would look like. Okay, so that brings us to our third one, and this one is pretty tough. The first thing I want you to notice is you're definitely going to use the chain rule because you have a function inside of the parenthesis there where you have the 5th power. So that's definitely a function. But you also have this piece out here. So you'll notice you have two separate functions being multiplied together. Well, that's the product rule back from a previous section. So remember, your product rule says you're going to take function 1 and deal with its derivative, and you're going to take function 2 and deal with its derivative. So function 1 is x squared, and function 2 is 2x plus 3 to the 5th. Now, the derivative of x squared is just 2x. We should be good with that. But the other derivative, we're going to have to use the chain rule. So in this particular problem, we're going to use the product rule and the chain rule. So the chain rule here says bring your 5 down, keep your 2x plus 3, decrease the power by 1, and don't forget to take the derivative of the inside. So the derivative of the inside is 2. So when I clean up this little expression right here, the 5 and the 2 go together to give me a 10, and 2x plus 3 to the 4th would be the remaining part. So that right there will be my D2. Now, let's put it all together. So remember, the product rule says you're going to use function 1 times the derivative of the second plus function 2 times the derivative of the first. So that's what we're going by here. Okay, function 1 is x squared. D2 is 10 times 2x plus 3 to the 4th. 1 D2. 2 is 2x plus 3 to the 5th. And D1 is 2x. Now that's how the calculus part goes. And even though it started out tough, hopefully you can see how all of that lines up. Now here's where the troublemaking part comes in, and that is that you have to simplify this. And the way we simplify it is by factoring. The way we factor this is by looking for a greatest common factor. If I look at these terms, I notice that they all have a common factor of 2. Okay, so let me point that out kind of in red. Here's a 2 right here. 10 is also divisible by 2, so that's where I got the 2. You'll see that they also each have an x. Okay, this one has an x here, and this one has an x as well. So remember, if you have a greatest common factor, you're going to pull out the smallest one. So that's where the x came through. For the last factor, you'll notice that they each have a 2x plus 3. Now, when you factor out the 2x plus 3, you're going to take out the smaller one. So the smaller one is 4. So hopefully that shows you where the greatest common factor comes from. So now we have the colorful group out in front. We have to factor that out and see what's left behind. In the first group, I have a 10x squared. I'm taking out a 2x. So 2 times 5 would give me 10, and x times x would give me x squared. So looking at this particular piece, 2x times 5x would give me 10x squared, and I have a 2x plus 3 to the 4th, so this piece has been satisfied. Okay, so let's go to the next one. I took out the 2x, so that means I took out this entire piece here, and I took out 4 2x plus 3's. Well, that means there's one 2x plus 3 that remains. So what I have in front is a 2x times 2x plus 3 to the 4th. And what I have left in these brackets would be 5x plus 2x, which is a 7x plus 3. Now I use brackets there, but you could definitely use parentheses as well. So we use the product rule and we use the chain rule, but I think the hardest part of all of that would be the factoring of it. So that's how that one would look.